Bismillahirrahmanirrahim. Let's go over the process for the light compensator design. Last time we did the integrating networks, and today we'll discuss the lag compensator design on the body plot and on the root logos. Remember, a lag compensator is nothing but a pole and a real pole, a real zero, and the transfer function for the lag compensator is uh, GC lag is 1 plus tau s over 1 plus tau alpha s. Alpha is greater than 1 again. The body plot for the compensator is magnitude plot and a phase plot, and the pole will be at a lower frequency compared to the zero. So pole is at 1 over tau alpha, and 0 is at 1 over tau with a negative sign. So alpha is greater than 1, so pole will be at a lower frequency compared to the 0. So magnitude subtraction will start at a lower frequency, and then the addition in the magnitude will start at a higher frequency. The body plot for the lag compensator looks like this. Suppose this is 1 over tau alpha, means this is the corner frequency of the this is the corner frequency of pole, and this is the corner frequency of 0. 1 plus 1 over tau is the corner frequency of 0. So the body plot will look like this. It will start at 0 dB, and at 1 over tau alpha it will be minus 3.01, but asymptote curve it's just 0. And then the subtraction will start. Subtraction in magnitude with the minus 20 dB per decade, and when we reach the 0 it will add plus 20 dB per decade, so minus 20 dB and plus 20 dB effect will be cancelled out, and curve become horizontal for the magnitude body. Magnitude in dB, so curve become horizontal, and these are the corner frequencies. So, and this we already calculate, this will be minus 20 log alpha negative, because this is on the negative side, and if you calculate you'll find out the value is negative. Now what about the phase plot? You need to just mark the position of the corners on the phase. This is 0 degree phase, and the phase plot will look like this, that you need to go 1 decade before and then 1 decade after. And at corner it will be minus 45, so it will start at 0. It will be minus 45 at the first corner, minus 90 at the second corner, and then once we reach 1 decade uh, before the location of 0, it will start rising with a slope of plus 45 degree per decade. At corner uh, it will be like this, and after the 1 decade after 0 it will be fully established phase, which is 0. So this is the asymptotic curve, and if you draw the actual curve, that will look like this. It will be smooth curve, no corners, and actual curve, if you plot with a MATLAB, it will be smooth curve, and this is the point where omega corresponding to phi min. So now remember, the phase is fully established after uh, 1 decade of ahead of the location of zero. Phase is fully established 1 decade after the corner of zero, right? So you need to go 1 decade and then phase will become almost zero. So we'll use this to design a controller. The steps are very simple. And the steps. Step one, draw the original system body. Original means uncompensated. System body. Plot. Check the phase margin and calculate the phase margin needed using design specification. Calculate the existing phase